Next one that is, okay, so first we're going to talk about your growth hormone. Now, guys, when we talk about these hormones, right, every now and then we are going to be talking about its hypersecretion and hyposecretion. Okay, so each of them will be having some or the other diseases associated with it. Okay, and you need to remember this. Okay, so first one, guys, let's try to move ahead with the first one, that is the anterior lobe growth hormone. Okay, let's figure it out, like, what is happening. Okay, so hormones of the anterior lobe. Okay, so first one, guys, I said we are going to have growth hormone. But now remember, guys, this growth hormone has several other names. Okay, so like what? So, guys, we can just call this thing as GH. Okay, to start off with, we can just call this DH. Or we also call this thing as somatotropin. Okay, now, guys, I'm going to tell you one term out over here. Okay, so tropin. Okay, let's, what is this tropin that we're talking about? Okay, so see, because I had told you, if you remember, we said growth hormone, it is your somatotropin, thyroid stimulating hormone, thyrotropin, adrenocorticotropic hormone, corticotropin, gonadotropins, right? So basically, what is this tropin? Tropin actually stands for a set of hormones which can control or influence the functioning of other endocrine glands. Such kind of hormones, we call them as tropic hormones. Okay, so this is something which is very, very important. Okay, it is always asked in your exams, guys, especially in your boards. They ask you to define what are tropic hormones. Okay, so we call this thing as your somatotropin, or the other name is your somatotropic hormone. And somato. Okay, so somatotropin or somatotropic hormone. Okay, or we also call this thing as STH. Okay, so guys, many names for the same thing, but remember, you need to remember all of them in your minds. Okay, so just keep this thing in mind. Okay, so once again, I'll just talk about this so much. Okay, so somatotropin. Okay, so guys, when we talk about this tropin actually comes from the term tropic hormone. So basically, see this thing, tropic hormone. Now, what are these? These are the hormones which influence the functioning of other endocrine glands. Okay, fine. Chalo. But now, guys, let's try to move and let's try to see what is the job and how is it really going to be influenced by. Okay, so guys, there are many hormones which are going to be like influencing the production and the stoppage of your growth hormone. Okay, so let's try to see one by one who is it going to be influenced by. Okay, so first thing, guys, this is influenced by. Okay, the first one is your growth hormone releasing factor. Okay, so we say GHRF. Okay, so whenever we have GHRF produced by your hypothalamus, that thing is going to stimulate your pituitary to produce your growth hormone. So that is why we say, okay, it is influenced by one growth hormone releasing factor. Okay, so this is produced by your hypothalamus. Okay, so you need to keep this in mind. I've already told you guys that your hypothalamus, this is going to be the real master gland. Okay, and pituitary is just going to be the coordinator of your endocrine orchestra. Okay, so just remember that. Second thing is, guys, just like how it is going to be stimulated by growth hormone stimulating, that is your releasing factor, it is also stopped by your growth hormone inhibiting factor. Okay, fine. So this is going to be your GHIF. But then the third thing that is also going to influence whether it should be produced or whether it should not be produced is your PIF. Okay, so one is that, and another one is going to be your somatostatin, guys. Okay, okay. So when we talked about this somatostatin, okay, guys, this was produced by your pancreas, if you remember. So somatostatin, it maintained a balance between both your insulin and glucagon. Same thing. This is also going to do the same thing out over here, guys. Okay, so this is also going to help regulate your the production of your growth hormone. Okay, so that's it. So this is what we need to know with regards to the influence. Okay, but now what is this really going to do? Like, what is the basic function? Okay, why do we require growth hormone in our body? Okay, so when we talk about this, it is just going to bring about the basic growth of the body. Okay, so like overall basic growth, irreversible increase in the height, size, or weight of your body parts. Guys, once again, when I say weight, what does it mean? It means we are talking about the bone weight. We are talking about your actual weight. Uh, GHIF is produced by your hypothalamus. This is also produced by hypothalamus. GHRF, GHI, both by hypothalamus, and somatostatin by pancreas. Okay, so basic growth of the body. Okay, second thing. Okay, along with this, what is this going to do? This is going to bring about linear growth of the skeleton. Okay, so what happens is, guys, as we are growing, the skeleton should also increase in proportion to it. Okay, so it is linear growth of the skeleton. Then next thing, this is also going to help in the development of muscles. Okay, next it is also going to help in the development of all your connective tissues. Okay, so that can include your blood, it can include your lymph, it can include your areolar connective tissue, it can be your bones, it can be cartilages. Okay, so all of this, ligaments, tendons, all of them. Okay, but along with this, guys, see, while your body is like growing, okay, at that time you're going to require huge amounts of energy. So huge amounts of energy, huge amounts of repair, huge amounts of replacement, all these things are going to happen while you are growing. So what it does is it is going to help in increasing protein synthesis. Okay, so protein synthesis. Next, it is going to increase your lipolysis, meaning breakdown of your lipids. And why is that so? So that your body can have good amounts of energy. So by lipolysis, we are going to produce your fatty acids and glycerol, and these can now be used for providing energy to your body. Okay, and finally, guys, this is also the one who is going to help strengthen the bones. Okay. So, guys, these are some of the most important functions of your this thing. Sir, what's the work of somatostatin? Somatostatin, if you remember, once again, it is going to be produced by your pancreas. Okay. And when we said it is going to be produced by pancreas, we had said that, oh, this is the one which maintains a balance between your glucagon and insulin. But at the same time, this is also going to help in the balance of your growth hormone. And that is why the name somato. Okay, so that is why we had said it is going to be your somatostatin. Okay, the reason for this was, see, soma means body. So it is going to regulate your body growth, meaning it is going to maintain. So that is why it is somatostatin. And in fact, when we talked about this, I told you that when we'll do this thing, your pancreas, while we are doing the pancreas, I told you that somatostatin will also help in something growth, but we'll talk about it in your pituitary gland. Okay, so this is the same thing. It's just going to help maintain balance. Okay, so this is it. But now, guys, once again, we are going to see what is your hyposecretion and what is hypersecretion. Okay, so really, really important. And guys, this is like really asked in your exams. Okay, so very, very important from this part. Okay, so guys, we have your growth hormone, and I'll just put it down growth hormone, and now we have hyposecretion and hypersecretion. Okay, so I'm just putting it this way, so that it becomes really, really easy to understand. Okay, so now hyposecretion we can have like in two things, like either you will have hyposecretion in your children, or we can also have this thing in adults. Same way, hypersecretion in children and hypersecretion in adults. So let's try to figure out what is going to happen. So guys, if you are having hyposecretion of growth hormone in children, okay, so tell me, if there is no growth hormone, will your size of the body increase by any chance? No, right? So you are going to remain like really, really short. You are going to remain really, really dwarf. So, guys, what are you going to suffer from in this case? You are going to suffer from dwarfism. Okay, now this dwarfism, this can be called as pituitary dwarfism also. Okay, but then dwarfism. But guys, you remember when we talked about dwarfism, we have seen dwarfism somewhere else as well. Can anybody tell me we talked about dwarfism somewhere else as well? Anybody in some other disease? Anybody? I'll give you a hint. It was Down syndrome. No, 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 not Down syndrome. In this chapter, right now, we have talked about it. You are going to be marred by Down syndrome. You're going to be marred by your dwarfism and mental retardation. Yes, very nice. Neha Singh has given me the right answer. Parnavi is also right. Okay, so it was hyposecretion of your thyroxine, guys. That is going to result into cretinism, so mental retardation and dwarfism. But now here, guys, when we talk about dwarfism can be of two types. Okay, so here you can either be mentally stable or you can be mentally retarded. Even this is going to be possible out over here. Okay, so dwarfism is going to be of two types. Okay, either you are going to be frolic. Okay, so we have frolic dwarfs or we have Lauren dwarfs. Okay, so Lauren, frolic, and Lauren. Okay, but now if we talk about frolic, okay, Lauren can be also spelled by another name, huh? This way also. So this is another way of spelling this. Okay, so frolic are the ones who are going to be mentally retarded, whereas Lauren are the ones these are going to be mentally normal. Okay, but at the end of the day, both of them they are going to be dwarfs only. So that is always going to be there. Okay, so this is dwarfism, guys. Okay, so frolic dwarfs and your Lauren dwarfs. And then, if by any chance the same thing happens in your adults, okay, then what do you suffer from? You are going to suffer from Simmons disease. Okay, so this is what is going to happen now. Once again, in Siemens disease, like basically you are an adult and suddenly there is hyposecretion of growth hormone. Then what happens? You're going to have less amounts of protein, less amounts of energy, lethargy. Okay, so bones become like weak. All that thing is going to happen in your Siemens disease. Okay, but now let's try to see hypersecretion, guys. The hypersecretion you can have once again either in children or either in your adults. Now, if by any chance, sir, that Coca-Cola size bottle girl is an example of dwarfism, yes, absolutely. That is dwarfism only, and she is suffering from frolic dwarfism. Okay, because she is mentally normal. Okay. Sorry, she's suffering from your Lauren dwarfism because she's mentally normal. If she had been floric, then she would have been mentally retarded. Okay, but now, guys, let's imagine we are having hypersecretion in your child. Now, if there is hypersecretion, suddenly this child is going to go like a coconut tree. Okay, really, really huge. What is this going to be? This is called as gigantism. Okay, so you are going to be really, really tall. Your bones are going to be extremely long. Okay, however, you are going to be so tall that now you can't even walk properly. Okay, you will have to get the help of clutches. So if you know that, the tallest man, the one in China. Okay, if you have ever seen him, he cannot just stand like that. He needs to have clutches on. Okay, otherwise he's just going to fall off because he is too high. Okay, so it results into gigantism. But now this is when you are going to be a child. Let's imagine the same thing happens when you're an adult. Then what are you going to suffer from? Guys, you suffer from another disease which is called as acromegaly. Okay, acromegaly. Okay. So guys, acro meaning top and megaly means huge. So here, what are you going to suffer from, guys? You are going to suffer from huge head. Okay. You are going to have you are going to have a very, very big head. Basically, big head. You are going to have enlarged or big, broad jaws. Okay, broad jaws. Apart from that, guys, you are going to have long limbs. Okay, so whether it is your hands, whether it is your legs, both of them, they are going to be long. Okay, if you look at fingers are going to be like exceptionally long. Okay, so basically you are going to see, like, you are going to be a little disfigured. Okay, meaning you're not going to look like a normal person. Okay, so disfigurement. Okay, so guys, if you want to remember, like, who is the one who is, like, one of the famous things suffering from acromegaly, guys, this person is nothing but your Khali. Okay, if you are into WWE and if you know this person, guys, so Khali, basically, he is the one, like, the moment you see this guy, Khali, you know for sure that, this guy, he is not a normal person. Like, he is like, there is something wrong with him because his entire body is like, his chest is like something different, hands are like, really long, then his face is like, it looks odd. Okay, and plus the moment he starts speaking, you don't understand what is he saying. He needs to have, like, a translator. So all these things are going to happen in your acromegaly, guys. Okay, so everybody all right at this time? Yes, right, right. Okay, so this is the first thing that we need to know, guys, with regards to your growth hormone. Okay, so now after your growth hormone, let's try to move on to the second one, guys. The second one, we said it is going to be your thyrotropin. Okay, so see, guys, everywhere we are going to use the term tropin, and that is why they will always ask you what are these tropic hormones. Thyrotropin. Yes, yes, yes. Tallest is that guy from China. Okay, 8 feet something. Okay, so thyrotropin or thyroid stimulating hormone. 9 feet, I don't know. And now he's going to grown to 9 feet. I have no idea. The last time I remember it, he was somewhere around 8 feet or something. But 9 feet, I'm not so sure. Okay, so you can find it out and let me know also. Okay, so thyrotropin or thyroid stimulating hormone. Okay, or just plain we call this thing as TSH. Okay, so let's try to see what is this going to do. Now, first of all, see, just like how we had a regulation basically of your growth hormone, so here the regulation is brought about by whom? Meaning, who's going to help it produce, who's going to help it stop. So this is going to be produced by your TRF, that is thyrotropin releasing factor. Okay, so just keep this thing in mind. This is thyrotropin releasing factor. Once again, who is producing all these releasing factors? It is once again by your hypothalamus. Okay, so this is the guy who's producing this. Okay, but now how does this thing work? Okay, now I'll just give you a quick idea. Okay, Regulation is brought about by TRF, but then this is going to be by your negative feedback mechanism. Okay, so first we need to understand what is this negative feedback mechanism. Okay, so now let's understand this thing, guys. Okay, this is sometimes asked in your NEET exams, okay, not in your board exams. Okay, so when we talk about this feedback mechanism, guys, there are actually two types of feedback mechanism. Okay, so I'll just make it really, really simple for you guys. Okay, feedback mechanism is basically a method by which the body comes to know what is exactly going to happen. Regulation meaning whether it is to be produced or whether it is not to be produced is done by your TRF. Okay, so this feedback mechanism, it can actually be of two types. One, like if it is one positive, and second it is going to be negative. Okay, now what is the difference between positive feedback mechanism and negative feedback mechanism? Guys, in your positive feedback mechanism, now please pay attention. Okay, if the body is doing certain activity or something is happening, okay, so the body activity continues to take place. Okay, it continues to occur without any correction. Okay, it continues to occur without any kind of correction. So for example, guys, let's say for example, you are urinating. Okay, this is hypothetical example just to make you understand. If you are urinating, and if it is a positive feedback mechanism, you will continue to urinate, it will not stop. Okay, so there is no stopping or there is no adjustment which is brought about. So let's say if you are having tremendous amounts of pain, then the pain is going to keep on increasing slowly. Okay, that is positive. So body will not bring about any kind of reinforcement, and it is not going to bring about any kind of change. That is positive feedback mechanism. Guys, examples of positive feedback mechanism are very, very rare. One of the most common examples is nothing but at the time of labor pains. Okay, so you will see the same thing is going to happen when you are about to deliver labor pains. Okay, so what happens, guys, at that time? Okay, you are in the hospital. Okay, and then you are having, like, huge amounts of contractions in the uterus. As you are having contractions in the uterus, the pain is increasing. Now what should your body do, guys? If the body is hurting by any chance, it is your body's duty to stop the pain. It is its body's duty to cut down the pain or cut down the the effect. But does it happen in labor pains? No. When the labor pains start, initially they are going to be low, then they are going to increase, and then the intensity of pain is also going to increase until the baby is going to be pachak thrown out of the body. Right? So that is positive feedback mechanism, because we are not bringing about any kind of correction. If the pain is increasing, let it increase. Okay, so understand this thing, guys. However, when we talk about your negative feedback mechanism here, if there is a body activity and if your body doesn't like it, correction is going to be brought about. Okay, so correction is going to be brought about to adjust the body activity. So for example, how this is going to be: maintenance of your glucose levels in the body. I'll just talk about a thyroxine so you'll understand what exactly is happening. Maintenance of glucose in the body, maintenance of your thyroxine in the body. Okay, etc, etc, etc. Okay, so guys, first let's try to understand what is going to happen in your thyroxine. Okay, so let's imagine we have our hypothalamus out over here. Okay, now I'm just going to separate these things out, okay, guys, so that you understand properly. Okay, now let's say this is your hypothalamus. Let's say this is your pituitary. Okay, let's say this is your thyroid gland. Okay, and guys, once again, please pay attention, okay, because in your textbook this is somehow missing now. Okay, so now what is going to happen, guys? Let's say I want to increase the production of your thyroxine. For some or the other reason, thyroxine is not being produced. I need to increase it. Okay, so let's say there is decrease in the thyroxine levels. Okay, now what happens is, if by any chance there is decrease in the thyroxine levels, these low thyroxine levels, they are going to go and they are going to alert your hypothalamus. Okay, so they are going to go to the hypothalamus. Now, the moment the hypothalamus is alerted, guys, what is the hypothalamus going to do? Hypothalamus is now going to start producing your TSHRF, thyroid stimulating hormone releasing factor, or TRF, thyrotropin releasing factor. Okay. Now, what is this thyrotropin releasing factor going to do? It is now going to travel from the hypothalamus and it is going to affect your pituitary. Now, it goes to the anterior lobe of the pituitary and tells him that, oh, the thyroxine levels are really low. You need to do something to increase the thyroxine levels. Immediately, what is the pituitary going to do? Oh, pituitary is going to analyze the situation and he is like, oh, okay. The thyroxine levels are dropping. I need to increase the thyroxine levels. What is this going to do? Immediately, this is going to start producing your TSH. So now the anterior lobe starts producing TSH. So you are going to get TSH. But now, the moment you have TSH, guys, what is going to happen? This TSH is going to travel through your blood and it is going to reach the thyroid. The moment it reaches the thyroid gland, what is the thyroid going to do? Thyroid is going to start producing your thyroxine. And now, as it starts producing thyroxine, what is going to happen? The levels of thyroxine in the blood are going to increase. So, see, guys, here aren't we trying to bring about some kind of your adjustment because there was low level of thyroxine. Now, slowly, we are getting high levels of thyroxine, right? Just have a look. First, just see and if you have understood this thing. Okay, so the other thing is, sir, if you want to stop urinating, if someone calls us urgently, then is it muscular control, right, sir? Not any feedback mechanism. Yes, absolutely. But however, you cannot control your urine for much longer. I'll tell you what happens is in your males, there are going to be two sphincters. One sphincter, that is the urethral sphincter, which is going to be at the base of your urethra, basically where it starts from the urinary bladder. That one. And the second one is going to be right there in the penis. Now, what happens, see, when you are urinating, okay, what happens? The one which is at the base of the urinary bladder, that is going to open up under your spinal reflex. Okay, but the one which is there inside the penis, you can try to stop it. Okay, now you're not going to have 100% control out over there, but you can try to stop it. Okay, but then once again, if you try it, you yourself will understand that you cannot hold it for a long time, because if the urethral sphincter is like opened up, then the pressure is going to be so much that suddenly, you have to give it off that way. Okay, so yes, it is going to be muscular control, but then still it is not going to be 100% under your control. Sir, then there is one more thing. Sir, there is this injection epidural block to stop the labor pain. Like, does it harm or anything, or will it really stop the pain? So what we do is basically, you see, whenever we take any kind of painkiller or any kind of injections like that, their main job is to go and block the pain receptors. Okay, see, when are you going to experience pain? Only when the pain signaling molecules, they bind with the pain receptors, and the pain receptors then respond accordingly, and then they're going to send signals to the brain. So here what happens is we are going to block the pain signals, okay, by giving those injections. Now once the pain signals are blocked, the pain receptors are blocked. Now what happens? Now there is no further communication, no further communication, so your body does not understand that it is pain. The same principle is in your anesthesia. Okay, so during your your like operations and all, we give anesthesia, local anesthesia, sometimes we give general anesthesia. Okay, it works exactly in the same manner. Yes. Okay, at the same time, but if you have that anesthesia, then guys, also remember, you will have a little bit of different feeling, it affects with your mental ability also. So suddenly you become a little high kind of a thing. So you can see videos and all, okay, where people in the influence of anesthesia, they start acting like a little crazy. All their inner side comes out. Okay, it's really fun to see those videos. Anyways, chalo. Okay, so guys, see here, this is going to be your negative feedback mechanism. I hope everybody has understood how we have brought about the arrangement. Okay, sir, can people have allergy to anesthesia? Yes, absolutely. They can also develop. Yes, yes. Because anesthesia basically is for, it is something foreign, right? So whenever it is given, maybe the components may interfere with your body's immunity. So yes, definitely. Uh, it is done for criminals. Yes, the narcotic test, if you know, it is done in the same manner. They try to bring you in a level where you are like almost really into trance kind of thing, and then they try to get uh, the truth out of you. However, according to the Indian courts, it is not a legal procedure. Okay, so whatever that is said in the polygraph in not the polygraph test, but the narcotic test is does not hold true in court. Anyways, sure. Okay, so guys, but now let's imagine the thyroxine levels are increasing. Then what? I need to bring down the thyroxine levels also. How am I going to do that? Okay, so now understand this thing. Okay, so okay, color. Ah. Okay, so now because the thyroxine levels are increasing, let me just put it down. So we have increased thyroxine levels after some time. Okay, now if I am having increased thyroxine levels, now the body needs to bring it down by some or the other way, right? Now, what is going to happen? How is the control going to be brought about? Let's try to figure this thing. Okay, so guys, see what is going to happen is as the thyroxine levels are increasing, the increased thyroxine levels, they are first going to go and they're going to alert the thyroid gland. They're going to tell the thyroid gland, okay, stop, enough. There is enough amounts of thyroxine. Stop the production of thyroxine. Thyroid gland is like, okay, as the thyroxine is going to alert the thyroid gland, thyroxine says, okay, I will stop the production of thyroxine. So immediately it stops this thing. Okay, so guys, see, orange color is only when we are having high levels. Okay, otherwise it is going to follow this method only. Okay, fine. Chalo, but now if the thyroid has stopped producing your thyroxine, isn't the thyroxine level going to decrease? Yes, right? But what does the thyroid gland say? The thyroid gland tells the same thyroxine that, oh, I am not the culprit. I am not like really producing thyroxine. Who is telling me to produce thyroxine? It is going to be your pituitary. So you go and talk to the pituitary. So the same increased thyroxine levels, now they are going to go to the pituitary, and they are now going to alert the pituitary, and they're going to tell him that, oh, enough, now we are having increased amount of your thyroxine stop the production of TSH. Okay, so pituitary is like, okay, fine, I am stopping the production of TSH. So now there is no TSH, there is no TSH, so there is no thyroxine, thyroxine level decreases. But once again, what does the pituitary say? The pituitary says, Ari, but it is not me. I am not the one who's like, really producing. It is hypothalamus who's sending me the signals. Now you go and talk to the hypothalamus. Okay, so once again, the increased thyroxine levels, they are now going to go to the hypothalamus and they are going to tell the hypothalamus to stop the production of your TSHRF. Now, there is no TSHRF, no TSHRF, no TSH, no TSH, no thyroxine, and eventually you are going to see that the thyroxine levels are going to decrease. This is how that entire cascade is going to work, guys. Yes, absolutely. Yes. Okay, government office system, something of that sort. Absolutely. Okay, so this is what we need to know with regards to your positive and negative feedback mechanism. I hope everybody is clear with this thing, guys. Fine. Okay, but now let's try to see what are the diseases. Now, guys, diseases are the same thing because see, what is going to happen? TSH basically it is going to influence your thyroxine, and even if there is hypo or hyper secretion of TSH, it is nothing but hypo or hyper secretion of thyroxine only. Both of them they are negative feedback mechanism only. Positive feedback mechanism is labor pain. This is we are trying to bring about adjustment in both the cases. We This is negative feedback mechanism only. Okay, this is not positive feedback mechanism. If you want अब मैं क्या करूँ 1 minute. Yes. Okay, I will just put it here. जाने दो. Okay, fine. These are two ways in which regulation is going to be brought about. Okay, but now guys, let's try to quickly put down your hypo and hyper secretion. Once again, it is exactly the same thing. So once again, we are talking about thyroxine, it's TSH. Okay, so we have TRF or TS, thyroid stimulating hormone releasing factor. Guys, once again, how we are going to have hyposecretion and hypersecretion. Okay, once again, the same thing, guys. Again, nothing new. We're just going to put it down once. Okay, so we are going to see first thing, this is going to happen in your children, and second, it is going to happen in your adults. Okay, so hyposecretion, guys, what did we say? We are going to suffer from your simple goiter. Simple goiter is common for both. Okay, so let me just put it down in between. Okay, so this is going to be simple goiter for both of them. Okay, but now only in children, what are we going to suffer from? This is going to be cretinism, and in your adults, it is going to be myxoedema. Okay, fine. And now, if we talk about your hypersecretion, guys, hypersecretion, there is only one, and that is nothing but your exophthalmic goiter. Okay, so only one thing out over here, exophthalmic goiter. Okay, and also remember, guys, some people, like, I was checking a few papers a few days ago, and some people had written instead of exophthalmic goiter, they had written exophthalamic goiter. Okay, guys, the moment you write it as exophthalamic, thalamic means something different. It has to do something with your thalamus. So that is different. Okay, so that is wrong. So always remember it is exophthalmic. Okay, meaning it has to do something with your eyes, protruding eyes. Okay, so that way. Okay, so that is it. So that is what we need to know with regards to your TSHRF. Okay, but now let's try to move on to the next one, guys, and let's try to see your adrenocorticotropic hormone or your corticotropin. Okay, so ACTH, adrenocorticotropic hormone. Exophthalmic, yes, it is going to be common. Okay, this is only one. Common for both. Okay, adrenocorticotropic hormone, or this is known also as your corticotropin, or also known as your adrenocorticotropin. Okay, fine. Okay, so now the first thing is, who is the one who's going to bring about a regulation, meaning who is going to control this thing, who is going to help it produce this thing. So this is going to be regulated by your corticotropin releasing factor, or CRF. Okay, corticotropin releasing factor. Okay, and now as the name suggests, what is this going to affect? Immediately, this is now going to affect your adrenal cortex. That's it. So it is going to affect the adrenal cortex, and it is going to help it produce its own hormones. That's it. Okay, so affects the adrenal cortex and helps to produce its own hormones. Okay. And once again, guys, what have we talked about? Like, if we are going to affect the adrenal cortex is going to produce your cortisol. Okay. That is the one which is required for suppressing inflammation. And the second thing, we have your group of corticoids. So we have your mineralocorticoid, glucocorticoid, and your sex corticoid. So even those are going to be produced. Okay. Then once again, we have already spoken of, like, the hypersecretion and hypersecretion, guys. What is that going to result into? That is nothing but Addison's disease and Cushing's syndrome. So if we talk about this, so ultimately this is going to affect the functioning of your adrenal cortex. So hyposecretion, one, Addison's disease, and hyposecretion, Cushing's syndrome. Okay, if you remember, we had remembered them as all will. Okay, and then we had, like, contrasted with one another. Okay, so Addison's disease and Cushing's syndrome. That's it. That is what we need to know with regards to your ACTH. Okay, but now, guys, the next one that we are going to have, we have is your prolactin. So let's try to see what is prolactin, how is it going to work. So this is again one, it's again, like, this is very important. See, like how we said it in a growth hormone, that was very important. The prolactin is also very important. Generally, it is asked for 3 marks short note, or sometimes it is asked for, 2 marks. Like, what are the other names and what is the importance that way. Okay, so let's try to see prolactin. What really happens in prolactin? Now, guys, this prolactin, this is known by different names as well. Okay, first we'll see how it is regulated. So basically, this is regulated by PRF or PIF. Prolactin inhibiting factor. Okay, so PIF. Okay, but now let's try to see what really is going to happen and what is the job exactly. Okay, so guys, when we talk about your prolactin, always remember this has many names. First thing, we also call this thing as mammotropin. Okay, so the same thing, also known as mammotropin. Why? Because it helps in the development of mammary glands. So after your puberty, okay, suddenly there is an outgrowth or spurt in the development of mammary glands. How does it happen? It is because of excessive amounts of your prolactin. So development of mammary glands. Okay, second thing, guys, we also call the same thing as lactogenic hormone. Okay, lactogenic hormone. Now, lactogenic hormone, lactogen milk. So, guys, why? Because this is going to help in the ejection of milk during your lactation. Okay, so production and ejection of milk. Okay, during lactation. So that is why lactogenic hormone. Okay, guys, but then we have third name for this also. We also call this thing as luteotropin. Okay, luteotropin. Okay, now why is this also known as luteotropin, guys? Because this is the one which is going to help maintain your this thing, the corpus luteum. Okay, so it just like we have your luteinizing hormone. Same way, this is also going to help in the formation of your corpus luteum. Okay, so helps in formation and maintenance. Okay, of corpus luteum, and that is why we have this luteotropin. But guys, what is this corpus luteum going to produce? Corpus luteum is responsible for the production of your progesterone. Okay, so you need to keep this thing in mind. And what is progesterone going to do? Progesterone is the one who's going to maintain your entire endometrial lining. So that way. Okay, and then finally, the last thing, guys, what is this going to do? Prolactin. See, let's imagine you have had a baby right now. Okay, you have just delivered a baby. Now, just tell me, guys, if you have delivered a baby right this month, should you be pregnant immediately in the next month? No. Okay, that is not a good idea, and that should not happen also, because your body is undergoing a lot of stress at the moment because of the delivery of the first baby itself. So you should not be like pregnant immediately in the next month. So guys, what happens is during this period, okay, during this period after the delivery, it reduces the chances of fertilization. Okay, so it reduces the chances of fertilization. And during the lactation period. Okay, now these days what we have observed is, guys, because of your uh this thing, like because of your changes in your lifestyle, because of tension, stress and all, suddenly the prolactin levels in your body increases. Okay, and we have been seeing this quite a lot. Okay, and because of this, now what happens is females start suffering from having loads of pain. Then they start having a pain in the mammary glands, then irregular menstrual cycles, mood swings. Okay, even all that thing is going to be affected by the levels of prolactin. Okay, and plus what happens is there is a relationship between stress and prolactin. So if by any chance you take a lot of stress, suddenly the prolactin levels are going to increase. Then what happens, maybe, see, prolactin levels is going to increase. The corpus luteum is going to be maintained. Corpus luteum is going to be maintained. Progesterone is going to be maintained. So are you going to have your timely menses? No. Then the menses are going to be pushed a little ahead. So this is what is going to happen. And guys, if you don't know, whether you are suffering from prolactin high levels or no, then what may happen, suddenly you may take this thing as, oh, you are pregnant. Then suddenly this is going to result into some another level of tension. Okay, whether it is going to be happy stress or bad stress, then that depends upon the situation. But then this is another thing that may affect. Okay, so this is how it works. Okay, but now, guys, the next thing I want to talk about is your because once you are pregnant, the lactation. No, 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 no. Once you are pregnant, the lactation stops. No, 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 no. See, the lactation is going to start. When you are pregnant and all, at that time the lactation, it is lactation means what? Lactation is going to be milk production. So by the 7th or the 8th month, now the mammary glands are really developed and they are ready to give out milk. So when the baby has been delivered, the lactation starts. Lactation is going to stop, like, after, like, 3 years or 4 years. That way depends upon how frequently you are lactating the baby. So that way. Okay. But if we have another baby in less than a year, then now it is not going to be, like, less than a year, maybe in the next consecutive years. So basically, like, let's say after 4 months or something, you can still once again, have a baby. You can still conceive, like 3, 4 months, not immediately. Lactation is going to keep on continuing till, to 3 years minimum, that way. Okay, sir, I have a doubt. One of my kaki thought she was pregnant, so she took a home test and she got positive result. But when she went through a sonography, she was not pregnant. How? See, basically, what na? Uh, there are many things out over here in your doubt. First thing is, when she took a home kit test and the results came out to be positive, that is an indication that yes, she is pregnant. Maybe yes, she was pregnant. But then you don't do sonography in the, like, generally in the first month itself. Okay, you wait, you will always wait. But then let's imagine she has gone for a sonography and you have, gone for the sonography thing and you have taken the test. The thing is, the embryo is going to be so small that sometimes it is not really visible through your sonography. Sonography is not like your x-ray thing that, you can see everything like really clearly. Okay, you will just see a small blob, that's it. Okay, so maybe the embryo was too small to be detected and that is why she could not be, like, shown pregnant. But remember, immediately you wouldn't go, like, in the first month itself. Okay, you would. And how it works, even if you take one test, okay, like, one that, let's say you have taken Prega Sure or Prega News. Okay, so you have taken that kit and let's say you have tested it. Okay, and oh my god, you are like, oh, I am positive. Okay, now on the basis of only one test, you're not going to consider positive. You're going to do at least 2, 3 times. Okay, aaj kiya, it is positive. Tomorrow you do it, it is positive. Day after you do it, positive. Then it is like, baba, positive, positive. Otherwise, yes, like Arya has said, sometimes there are false positive results also. Okay, however, now technology has advanced so much that, false positive results are minimal, and this is on the basis of your antigen antibody reaction. Okay, so that is that. But then, like I said, this thing, you have to do it twice or thrice to make sure you are really pregnant. Okay, so that must have been the case. Or in the worst to worst case scenario, maybe she might have had, like, an abortion without even noting. Like, sometimes, we have miscarriages. So she might have gone through that without even knowing that it happens. Because sometimes what happens, the embryo is not going to be implanted properly into the walls of the uterus. So what happens sometimes, even while urination and all, there is a little bit of more pressure, sapak, the embryo, and it just falls off and it's going to go off through the vagina. You won't even know, like, what has happened that way. So there can be many things to what your question is. Okay, fine. Acha, guys, the next thing that we're going to talk about is your luteinizing hormone and your follicle stimulating hormone. These are all parts of your gonad stimulating hormone, guys. Okay, so let's try to see how it is. So, but for this, guys, I want you to tell me, like, how is your understanding about menstrual cycle and the hormones produced? Have you guys, like, really done it thoroughly and understood it properly, everything? Quickly, guys, quickly, because that is going to decide, like, how we are going to move ahead. Okay, so yes. Okay, chalo, ठीक है. Anyways, so we'll just see. Okay. Okay, so I'll start asking a few questions. Let me just start with this thing. Then maybe, if I feel that, we need to revise, then I'll quickly revise it. Okay, so next thing, guys, we are in the fifth one, that is your gonad stimulating hormone. Okay, or this is going to be our GSH. Okay, or the other name for this, guys, like I said, this is also being known as your gonadotropin. Okay, so GSH or gonadotropin. As the name suggests, this is going to act on the gonads to produce its own hormones. And now, who is going to be like regulating this thing? This is going to be regulated by gonadotropin releasing factor. So GRF. That is gonadotropin releasing factor. Okay, fine. But now, guys, in this thing, the first one we said we are going to have your follicle stimulating hormone. Okay, so follicle stimulating hormone or just your FSH. Okay, so guys, the first thing is follicle stimulating hormone. Who is going to produce this thing? Follicle stimulating hormone, and what is really going to happen? So basically, follicle stimulating hormone. Uh, yes. Anybody wishes to answer this thing? Like FSH. See, we said okay, FSH is going to come from your the anterior lobe, but what is this going to act upon? Follicle stimulating hormone. This is going to act upon something. Yes. Okay. So first of all, this is the one which is going to act. It acts on the ovaries. Okay. So it acts on the ovaries, and now in the ovaries, guys, where is it going to act? Actually, it is going to act on the follicle cells. Okay, it acts on the ovaries and then it acts on the follicle cells. Now, basically, when it acts on the follicle cells, now what happens is it helps in their development. Okay, so it brings about development. So whether it is your primary follicle, whether it is your secondary follicle, or whether it is going to be your tertiary follicle. So what happens is from your basic like primordial follicle, you go into your primary follicle, secondary follicle, tertiary follicle. That is nothing but your Graafian follicle. So this is going to go from primordial to your tertiary follicle or nothing but your Graafian follicle. Okay, and now, guys, the last thing that is going to happen is what is this Graafian follicle ultimately going to do? The Graafian follicle releases the ovum, right? So this releases ovum. So what do we say? Follicle stimulating hormone. This is also going to help in your oogenesis. Okay, so this is going to help in your oogenesis. I'm saying oogenesis, not ovulation. Okay, but now, guys, see, when we talk about FSH, okay, so we said okay, it is going to affect your follicle cells, right? But now what are these follicle cells going to do? Okay, now guys, please pay attention. Okay, so we said the follicle cells, they are now going to be influenced, but follicle cells, they are going to produce e- estrogen. Yeah, I should have asked you this thing. Okay, so guys, what are they going to produce? The follicle cells, they are going to produce your estrogen. Okay, and guys, how do you remember this thing? See, one is going to produce estrogen and one is going to produce your progesterone. Okay, and you will always find a little bit of confusion. Oh, follicle cells are producing estrogen or follicle cells are producing progesterone. Okay, who is that? Okay, so that way, because the other one is your corpus luteum. So, how do you remember, guys, follicle cells, estrogen? Always remember FO. Okay, follicle cells, estrogen. Okay, if you will remember this thing throughout your entire life, FO, you will forget what it means maybe, but you will just remember this thing. Okay, so follicle cells, estrogen. But now, the moment we have estrogen, guys, see, when is estrogen going to be produced? Follicle cells, they are going to develop in the first 14 days of your menstrual cycle. So when estrogen is produced, this is going to help in repair of your endometrial lining. Again, repair of endometrial lining. That is the job. Okay, everybody okay with this thing? Because see, follicle cells are going to develop in the first 14 days, because by the 14th day you're going to have ovulation that way. Okay, but now this estrogen, what is this also responsible for? See, I've told you estrogen is responsible for all the secondary sexual characters in females. Okay, that's it. But now, guys, in males, okay, this FSH, we are also going to see it in males. Okay, so this is all in females. In males, now what is this going to do? Now, FSH, follicle stimulating hormone. Here it was responsible for what, guys? I see, I told you this was responsible for oogenesis. In males, this is going to be responsible for spermatogenesis. Okay, that is your sperm formation. Here it was ovum formation. Here it is sperm formation. Yes, absolutely. Okay, so this is what is going to happen. So this ultimately this is going to give you your sperms, and that's it. Okay, but now even by any chance there is hyposecretion. Okay, now in males, okay, in males or females, let's see. So in the case of males, if there is hyposecretion of your FSH, guys, what is this going to result into? Less production of your ovum, so oogenesis won't happen, so your ovum may not be produced. In males, spermatogenesis may not occur. So ultimately, if by any chance there is in this thing, what will this result into? It may result into infertility that way. Okay, so this is your follicle stimulating hormone. Okay, fine. Chal, let's try to move ahead. Let's try to see. I hope everybody is okay with this thing, guys. Okay, chalo. But now, yes, ask me. Okay, but now, guys, let's try to see. Okay, the second one out over here, that is going to be your luteinizing hormone. Okay, so let's see how is that really going to work. Now, guys, luteinizing hormone or your LH. When is this going to be working the most, guys? This is going to work on the 14th day. Why? Because a sudden spike in your LH causes ovulation. Okay, fine. Just have a look. See. Okay, so guys, like I said, this luteinizing hormone, what is this responsible for? Guys, this is going to be maximum during the 13th or the 14th day, depending on what day you're going to have ovulation. Most of the time, it is going to be either your 13th or the 14th day. So this is responsible in females for your ovulation. Okay. But now, guys, the moment we have this luteinizing hormone, it has given us ovulation. But now, what is going to happen to the corpus luteum? I mean, basically, your after ovulation, the Graafian follicle, this will convert into your corpus luteum. And now, if we have this corpus luteum, guys, this is going to produce your progesterone. And if it produces progesterone, guys, now what is going to happen? You are going to see what is the job of progesterone. It maintains your endometrial lining. So guys, if you look at estrogen, estrogen repairs endometrial lining. Progesterone maintains the endometrial lining. So that now until the 28th day of your menstrual cycle, this progesterone is going to remain as it is. This corpus luteum is going to remain as it is. So if you look at the graph of progesterone, okay, what will happen? Initially, the progesterone levels are low, but after the 14th day, suddenly they are going to rise up like this. Okay, why? Because after the 14th day you're going to have corpus luteum, and corpus luteum starts producing progesterone levels are going to increase. And then what happens? Let's say this is the 28th day. On the 20th day, if by any chance you're not pregnant, then what will happen? The corpus luteum is going to be converted into corpus albicans. Now, if it is converted, will it still produce progesterone? No. Immediately, zoop, 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 the progesterone levels decrease. And as the progesterone levels decrease, guys, what is going to happen to the endometrial lining? Endometrial lining cannot be maintained, and immediately, doop, 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 you are going to have the menses, meaning you are going to have the bleeding phase of your menstrual cycle. Okay, all right with this thing. Okay, corpus luteum, progesterone. Okay, always remember this thing: corpus luteum, progesterone, and follicle cells, estrogen. Okay, that is why I said remember FO: follicle cells, estrogen, corpus luteum, progesterone. So this is how it is really going to work, guys. Okay, so it maintains the endometrial lining. That's it. Okay, but now we are going to see luteinizing hormone in your males as well, guys. But now in males, this LH is known by another name. Okay, so what do we call it? Let's try to see. So in males, LH is called as ICSH. That is nothing but interstitial cell stimulating hormone. Okay, so what is this interstitial cell stimulating hormone? Guys, this hormone, this is going to affect your Leydig cells in the testes. It stimulates Leydig cells in the testes. Now, Leydig cells are also known as your interstitial cells. So, it is going to immediately affect your Leydig cells. And guys, what is Leydig cells going to produce? They are going to produce quickly, they are going to produce testosterone. So this is responsible for testosterone. So guys, how do I remember this thing? Okay, so you may always confuse yourself because every time you cannot just try to find out this analogy. Okay, so I remember this as follicle stimulating hormone. If it is follicle stimulating hormone, we are going to see oogenesis. If it is oogenesis, then it has to be spermatogenesis. And if it is your luteinizing hormone, then if it is helping in production of your progesterone, then it also helps to produce your testosterone. So hormone and process. Okay, so these two are processes that happen, and these two are the hormones. I always keep it in my mind in that fashion. You can have your own thing, or you can always try to deduce it, but then while writing, your during your exams and all, it is not going to be easy to always deduce what is happening. So you need to keep it in mind. Everybody okay with this thing, guys? And once again, when we talk about this testosterone, what is this testosterone going to do? Testosterone, this is responsible for secondary sexual characters in males. That's it. So that's it. So that is what we need to know about the hormones of your anterior lobe. After this, we have hormones of your posterior lobe. So guys, for the time, okay, so just have a look at this. And what we'll do is we'll break over here for 5 minutes, and once we come back, we will start with the hormones of the posterior lobe. Okay, so 5 minutes break, guys. 5 minutes break. Okay, chalo, guys. So let's try to move ahead. Let's try to see the next one, guys. So these were whatever we did right now. These were hormones of the anterior lobe. Okay, then we have the intermediate lobe. We said it is going to produce only intermittent, so that is not for us. Okay, but then let's try to see the posterior lobe. Let's see how it is going to work. Okay, so posterior lobe or your neurohypophysis. Okay, so the first hormone we are going to look out over here is, guys, your anti-diuretic hormone. Okay, so anti-diuretic hormone, or this is nothing but your ADH, or the other name for this thing we have also said this is going to be vasopressin. Okay, so yes. Okay, but now, guys, what have we said? Now we've already talked about your ADH, okay, and vasopressin in your excretory system. What is this going to do, guys? This is the one which affects your DCT and your common collecting tubule or your collecting duct. And what does it do, guys? It changes its permeability. It changes permeability and it helps to reabsorb water back into the blood. Okay, so reabsorbs water back into the blood. Okay, so this is what we had talked about with regards to your ADH. Okay, but now, guys, how is this ADH really going to work? So we have to see this thing once again. Okay, like how it was working, what really happened. So we had said, guys, if you remember, when there was low blood pressure, because of this, there was low GFR. Okay, low blood pressure, low GFR. But now the moment it is like, we are having this low GFR, what is going to happen? This is going to be recognized. This is immediately recognized by your osmoreceptors. Okay, it is immediately recognized by osmoreceptors, and what are we going to do? We are going to be producing more amounts of your produces basically osmoreceptors, and this helps in the production of your ADH. Okay, but now the moment we have ADH, what is this going to do? First thing, it is going to act on the blood vessels, because see, this is going to be your vasoconstrictor also. So it acts on the blood vessels, brings about vasoconstriction first. Okay, and as it brings about vasoconstriction, guys, what is going to happen? First thing, it is going to increase your blood pressure. And now, because the blood pressure is increased, therefore, slowly you are going to see that the glomerular filtration rate, even that is going to increase. That's it. That is what we need to know with regards to the effect of your ADH. Okay, but now, guys, let's try to see what is going to happen in hyposecretion, and if by any chance you have hypersecretion of your ADH. Okay, chalo, so let's try to see ADH hyposecretion first. So, guys, let's say once again, if for any reason you are not producing proper amounts of ADH, will the water be reabsorbed back into the blood? No, the water will not be absorbed back into the blood. So, what is going to happen in that case? You are going to give out more and more water in your urine, right? So, this is a disease which is called as diabetes insipidus. Okay, so remember, hyposecretion, this is going to result into diabetes insipidus. And what does this mean? It is going to mean more of water in your urine. Okay, now remember, diabetes mellitus. What did mellitus mean? Mellitus was honey like. Insipidus means this is going to be tasteless. So your urine is going to have so much amounts of water in it that it is completely going to be tasteless. It is going to not even have the tinge of saltiness inside of it. That is the idea. Okay, but now if you're having diabetes insipidus, guys, because of this, what are you going to suffer from? You are going to suffer from frequent urination. Okay, one. Second thing, Along with this, guys, if you are like urinating frequently, okay, this is called also called as polyuria. Okay, because of this, what is going to happen, guys? You are going to continuously feel thirsty. So I can say this increases the thirst. An increase in thirst is nothing but this is called as polydipsia. Okay, so you are going to see two things happening: polyuria and polydipsia in this case. Okay, this is going to be hyposecretion. But now let's try to see hypersecretion. Now, actually, this is not there for you, but let's try to understand. So, guys, if by any chance there is hypersecretion of ADH, okay, so there is more ADH, so more ADH, so more amount of water will be reabsorbed back into the blood. So, how is your urine going to be? In that case, your urine is going to be highly concentrated. You are going to have highly concentrated urine. Okay, so that's it. That is what we need to know with regards to your ADH. Very, very simple, very, very nice and short. Okay, next one, guys. After this, we said we are going to have your oxytocin. Okay, now oxytocin, once again, very, very important. Guys, this is also known as your birth hormone. Okay, why? Because this is going to help in the birth during your labor pains. And the second thing, this is also known as your love hormone, guys, because whenever you are in the process of making love or whenever you feel love for someone, at that time also oxytocin is going to be released so as to establish a bond between two lovers. That is why a love hormone. Okay, but now as we see what is going to happen, let's try to see, guys, in the case of your oxytocin. So basically, guys, what is going to happen? You are going to see that it leads to sharp contraction of the uterus. It leads to sharp contractions of uterus, and that is nothing but labor pain, and that is why this is going to be really, really famous for. So labor pains. Okay. Second thing, guys, you are also going to see that this helps in the ejection of milk. See, prolactin was responsible for production of milk. Here, this is going to result into ejection of milk. See, your mammary glands are producing milk, but that milk has to come out as well. Who's going to help it? It is your oxytocin. Okay, and the third thing that is does it, guys, this helps the helps in the fertilization process. Okay, helps in the fertilization process. So what happens is, okay, so when you are in the process of making love, at that time oxytocin is going to be produced, but oxytocin is going to bring about contractions of the uterus because see, it is like somewhat related to your labor pain kind of thing, right? So it helps in bringing about a little bit of contractions of the uterus. Along with that, when the semen is released inside the vagina, guys, semen is going to have what? It is going to contain your prostaglandins, right? There is one part which contains prostaglandins. Those prostaglandins are also going to stimulate contraction of the uterus. So prostaglandins, they are going to help in contraction of the uterus. Second, oxytocin is going to help in the contraction of the uterus. As a result, what happens? That entire semen, which is now liquefied, slowly it starts moving up towards the fallopian tubes. That is how it is going to work, guys. Okay, so third thing, as I said, this is also going to help in the fertilization process. That's it. That is what we need to know with regards to your oxytocin, nothing else. Okay, fine. After that, guys, we have the third one out over here, and that is nothing but your coherin. Okay, now what is this coherin going to do, guys? This is just responsible for the rhythmic contractions of jejunum. That's it. That is it, guys. So this is what we need to know with regards to the hormones of your entire pituitary gland. Okay, so just have a look at these, guys. Just see if you are okay. Then we will move ahead with the next part. Okay, now we are like done, almost done with all the important hormones and glands. Now we just have like a few which are there, like small things, like half of them we have already seen, some we need to just brush up. Okay, everybody all right? Okay, so now the last part of the chapter we're going to just the last part of the chapter we're just going to talk about a few hormones and stuff which we need to just brush up once. One minute, there is some question out over there. Uh, what is pituitrin? Is this related to ADH? Yes, but my question is, how did you know? Because this is a little thoda sa old term. The thing is basically, what we used to have this, like obtained from the cattles. So what we used to do is, we used to take some extracts from the cattles and which used to contain a mixture of this thing, ADH and your oxytocin. That is known as pituitrin. Okay, okay. Okay, but it is a very old term actually. Okay, so guys, the next thing we'll just talk quickly about. Okay, okay, okay. So we'll just quickly talk about the hormones of the gonads. Okay, now we have already mentioned this thing. We just need to put it down once. Okay, so guys, first thing we are going to talk about your ovaries. What are these ovaries going to produce? Let's try to see. So the first thing, guys, we said, what are the ovaries? The basic job of the ovaries, it is nothing but to bring about your oogenesis. But while it brings about oogenesis and ovum formation, at the same time, it helps in the production of different kinds of your hormones. So now, what are the hormones that are going to be produced? So guys, first thing, we are going to have estrogen. We already have spoken of estrogen, so basically responsible for all the secondary sexual characters, right? So one thing which is important out over here, guys, is that this is going to contain one most important thing, that is estradiol. Okay, so this is the main estrogen component out over there basically. Okay, so just remember estradiol. Okay, this is main estrogen. Okay, next thing, guys, we have said it is also going to help in the production of your progesterone. Okay, what is this progesterone going to do? Once again, it is going to help in maintenance of your endometrial lining. That's it. Okay, third thing, okay, we have out over there. Now this is a little different, guys. We have relaxin. Now what is this relaxin going to do? See, as the name suggests, relaxin, it means it has to relax something. So this is the one which relaxes the pubic symphysis, that is the pubic symphysis and the cervix, so that now the baby can be pushed out from the this thing. Okay, from the mother. So it relaxes the entire pelvic girdle. Okay, and the cervix, and this is going to be at the time of delivery. Okay, at the time of delivery. Okay, fine. And then the last thing, guys, out over here, we also have one more thing, inhibin. And guys, this is very important because in your NEET exams, this is always asked. I don't know why, but this is like a favorite question of your examiners. So, who is producing inhibin? This is produced by your corpus luteum. Okay, so corpus luteum is a part of your ovaries only. So basically, it is producing inhibin is being produced by corpus luteum. But what is this? This is the one which inhibits FSH and your gonadotropin releasing hormone GnRH. So guys, this is very important. Gonadotropin releasing hormone. In your exams, they always ask you this. Okay, so that's it. That is what we need to know with regards to hormones of your ovaries. But now let's try to see hormones of your testes. Now, what are they going to be? Okay, so first of all, guys, see, basically, hormones of your testes, like your testosterone and all, okay, these are nothing but your androgens. Androgens meaning what? They are coming from the males. So that is why androgens. Okay, so let's try to see the first one, guys. We have already spoken of this thing. We have testosterone. Testosterone responsible for all your secondary sexual characters. Okay, so that is what we have talked about. Okay, one very important thing that you need to know is if for any reason high levels of testosterone, they are going to inhibit LH secretion. Okay, meaning inhibit LH secretion. So here it is going to be nothing but your ICSH. Okay, so what is this going to do? As the level of testosterone increases, it is going to inhibit your LH or your ICSH in this case. So the Leydig cells will not be stimulated. Leydig cells will not be stimulated, so they will not produce testosterone. So the levels of testosterone will be maintained properly. Okay, so this is one very important thing. And another thing that is this testosterone going to do, like we have already said, this is going to give you secondary sexual characters. That's it. Okay, so that is what we need to know with regards to your entire hormones of your gonads. Okay, but now let's try to talk about hormones of your gastrointestinal tract. Okay, once again, this is all what we have done. Okay, we are just putting it down once, guys. In your digestive system, we have talked about all of these hormones of the gastrointestinal tract. So we said there are going to be four hormones out over here. Okay, so the first one we have said it is going to be gastrin. Guys, what is gastrin going to do? It helps in the release of your the gastric juices in the stomach. Okay, so it acts on the stomach. So one is gastrin. Second thing, guys, we have secretin. Okay, so second one was secretin. It helps in the secretion of your pancreatic juice and bicarbonates. Okay, acts on the pancreas. Third thing, we are going to have your cholecystokinin. Okay, but cholecystokinin, guys, this is also known by another name. See, first we could call this thing as CCK, or the another name is pancreozymin. Okay, okay, this is also known as PZ. Okay, what is this going to do, guys? This is going to stimulate your pancreas to produce your this thing, its enzymes, basically your digestive juices, and at the same time, it is also going to affect your gallbladder to release your bile. Okay, and the last one out over here, guys, we have your gastric inhibitory peptide. Okay, or GIP. Another name for GIP is enterogastron. Okay, GIP or enterogastron. Now, what did this do, guys? This is going to stop the movement of food inside the intestines so that now more and more amount of food can be reabsorbed into the body. That's it. That is going to be your GIP. And at the same time, this is also going to inhibit your gastrin production. Okay, so this is also there. Okay, then this is already, like, we have already mentioned all about this thing. So, not going into the details of it. Okay, then guys, we have your hormones of your heart. Okay, in your circulatory system, we have already done this thing. So hormones of wall of the heart. Can anybody tell me what is this hormone we are talking about, produced by your atria? Anyone? Anyone? What is this, guys? This is nothing but your ANF, atrial natriuretic factor. So, atrial natriuretic factor, guys, what is this going to do? You are going to see that this lowers down the blood pressure and brings it back to normal. And at the second time, this helps in the release of sodium ions in the urine. That is the job of ANF. Okay, so that's it. So that is the next thing. Then we have, guys, your kidneys. Okay, so if we talk about kidneys once again, let's try to see. When we talk about the kidneys, guys, once again, in your kidneys, we are going to have four different things out over there. Sorry, three different things. So first thing, guys, we are going to have your renin. Then second one, we are going to have erythropoietin. Okay, and then third one, we are going to have calcitriol. Okay, so once again, guys, renin, what we have said, this is the one which is responsible for increasing your blood pressure, increases your blood pressure. It is going to act as a vasoconstrictor type. Okay, we have erythropoietin. This is going to help in the formation of your RBCs. Okay, and calcitriol, this is going to help in the better strength of your bones. So this helps in the calcium movement basically. So that is nothing but your calcitriol. Okay, so calcitriol, if you look at this, this is nothing but an active form of your cholecalciferol. That is nothing but vitamin D3. That way. Okay, so guys, these are nothing but the different hormones that are there. Okay, and finally, guys, finally, we have one last thing, that is, what is your hormone therapy? Okay, so just a moment. Someone has messaged me, what is FT4 hormone? Now, FT4 hormone is, FT is, F stands for free. Free T4. See, we had talked about T3 and T4, right? Triiodothyronine and your tetraiodothyronine. So this actually is for your thyroxine, free thyroxine levels in the body. So maybe this must have been, someone must have asked to do this thing if you're suffering from either hypo or hypersecretion of thyroxine. So for that reason, you might have done this test. Okay, F stands for free out over there. Okay, so free meaning it is going to be in your blood. Okay, and guys, lastly, the last thing that is there is we have something that is called as hormone therapy. So, guys, what happens is sometimes there is a problem with your endocrine glands. And in that case, we do not produce the desired hormone. In such a situation, guys, we are given like hormones prepared from other organisms. Maybe it can be from humans by genetic engineering, or maybe it is going to be from other animals that have been obtained from them, and then they are going to be given it into your body. This is generally going to be done like after your menopause, or at the time of pregnancy, or like let's imagine you have like deficiency of your growth hormone, or let's imagine you have deficiency of your thyroxine. In those cases, we are going to go for your hormone therapy. So hormone therapy, this gives or provides hormones to the body. Okay, and this can be in many conditions, like whatever hormones that we were suffering, different diseases and all. To overcome them, we can use this therapy. So that's it. So with this, guys, we are finally done with your entire chapter. Okay, but guys, next time when we come back, we are going to do neat questions of this thing. Okay, so once again, the same way, guys, we'll start with that, the book, MTG book, and then we'll quickly finish this thing off. Okay, everybody all right with this, guys? Fine. Any doubts? Anybody wishes to ask anything? Oh, sorry, guys. 1 minute, 1 minute. There is one more small thing which is there. Okay, that is your how does the hormones work? Okay, no, I thought it has been edited out from your textbook this year. Anyways, take it. We have one small part that is remaining. Okay, that is like how is the hormone action, like the hormone receptor complex. Okay, it's very simple, nothing to really worry of. Okay, anyways, so I'll just give you a little bit of idea, but then it's a little bigger thing, so we'll do it like properly in the next class, but very simple as such. Okay, and next class, once again, your need session. Okay guys, always remember. Okay, so this is nothing but your hormones and the receptors, how the reaction really takes place. So you can also say this is going to be your hormone receptor complex, or like what really, how is the action going to be. So guys, always remember hormones and receptors, they are going to be very specific. Okay, very specific. It is always seen that, hormones, like we said, they are going to be produced in one part of the body, they're going to travel through the entire blood, but they're going to affect some other part of the body. So they are really specific. Okay, but now what happens is, where is the receptor present? Now remember, the receptors for specific hormones, they are present on the target organs. Okay, and now what is going to happen, let's try to understand. Okay, so guys, let's see, we have our cell. Okay, so let's say this is the cell membrane. Okay, now I'm just giving you one example. Okay, this can vary, but the idea remains the same thing. So let's imagine this is the cell membrane, and on the cell membrane we are going to have a receptor. So let's imagine the receptor is something of this sort. This is our receptor. Okay, now what happens is, guys, see, if you have ever played Tetris, okay, or jigsaw puzzles, okay, it is exactly the same thing, the lock and key model kind of thing. Okay, so what we are going to see is, we are going to have that, oh, here we are going to have exactly opposite complementary fit of your hormone. So the hormone comes out over here. Okay, now what happens? This hormone is traveling through the entire blood, but slowly, sometimes it is going to come in contact with this cell. So as it is going to come in contact with this cell, guys, see, you are going to have a situation like this. Okay, in the next case, you are going to see that this is going to completely fit into this thing like this. And when this thing is formed, guys, this is going to be known as your hormone receptor complex. Okay, this is our hormone receptor complex. And now what it does is, guys, this hormone receptor complex, this is now going to start off with your secondary signaling mechanism. And then those secondary signaling mechanisms, they are going to start a cascade, which is now going to make that, the cells start producing different hormones. But how is it going to happen? What is that secondary, signaling molecules that are going to come up, like calcium, inositol triphosphate? Okay, so all that thing we will, or cyclic AMP, that we will do it in the next class. Okay, everybody, all right? Fine. Chalo. So guys, once again, we'll stop over here for the day. Next class, we're going to start with the neat session of this part. Okay. Chalo. Bye guys. Bye bye. Take care. Bye everybody.